All right, so I just want to welcome everybody to our discussion of Chapter 15 for the R for Data Science book. Stefan has graciously taken on the discussion duties, and so we will be talking about regular expressions today. So I'm just going to turn it over to you, Stefan, and we'll fill in wherever needed.
Awesome. Thank you so much. Can everyone see my screen? Okay,
Yeah.
awesome. Okay, so today we're going to talk about regular expressions. And so the learning objectives are we are going to manipulate character vectors using a package called stringr, which helps us with a lot of string-related functions. We will use regular expressions, or for short regex, to match patterns in strings. And we will manipulate those strings. And then we will also look at other rules, how we can match strings in the first place using regexes. Okay, so the introduction is that, yes, like regex are incredibly powerful and go beyond like a usual control F search. Instead of just using for a specific word, you have like can look for specific patterns, and that's why it's a little bit daunting at first because those patterns are really hard to kind of parse if you're not used to it. And we will also see that in R, for a particular reason, it makes it also a little bit harder to sometimes read those patterns. Okay, so here it just points out that you can even find regular expressions in Google Sheets. And you will find it often also as an option in editors. Like there's often a checkbox. For example, also in RStudio, you can check and say you want to do search for a regular expression instead just for a direct match of what you're typing. So that's why it's really helpful to look for that. No regular expressions. Okay, so then it's here giving, I think, just a short explanation of how good, easy it is to write a function to actually match a certain pattern. I don't think we necessarily need to go into the details. Basically, it has those three different examples, and you want to make sure it's a valid, what is that, IP address. And so this is, as you can see, quite complex. And if you do it with a regular expression, you can now create this pattern here. And we're basically gonna go through what all these different symbols mean and how you construct a regular expression to search for certain text patterns or string patterns. And then it just shows that it actually correctly identifies these two. Yeah. So now in this, it explains all the different components of the search. I think it makes more sense to just start going through the stuff because we're gonna go through the individual components, but for whoever might watch this, return to this after the end and then be like, oh yeah, now I can parse all this information to understand this regular expression. Okay, one really neat function in the stringr package is the str_view because it will just show you what you're actually matching. And so then you can kind of have like a character vector with all kind of different strings in it and then see if you're actually catching the things you want to catch. And then apparently there's two more things, rec_explain, which is an add-in for a studio to help with regular expression. And then there's many, many websites. If you Google like help with regular expressions, then you will find many websites, but here's an example for that. Okay, so the most straightforward when you do a regular expression is exact match for the letters you're doing. So here the first argument in str_view is the character vector you're checking for patterns, and then the second argument is the actual pattern you want to see. And in this case, it's just berry. And then you see here in the output, you get all the ones in the fruit data set which have berry in the string. And those carets less than and greater than sign just shows you where it matched. So this is a straightforward and good step to see as you develop. It's like so many things in programming, an iterative process when you develop your regex to just check again and again to make sure you get actually a match. And I think there's a lot of horror stories about bad regexes which cause like, big downtimes because things suddenly stop working. I forgot. I think there was more last year. It was something where a big outage was, I think, caused by a bad regex. So in this way, you kind of can at least double check and do a sanity check if the things are working. Okay, so if you use regular letters, then it will just directly match those. But then it uses many different meta characters. And so it's these here listed. And so we just go through one after the other. So period mean it matches any character. And I think that includes also white spaces. And the only exception is a new line. So usually in a string, that would be a \n would indicate a new line. And that is not matched with a period. And then here in the example, we see, for example, it starts with an A, then 3 any characters, possible characters, and has to end with an E. And then you see all the things that match as an example. Then there's these other quantifiers. So if you follow it with a question mark, it makes it optional. So whatever character it follows means it can be there or can be not there. So 0 or 1. Then plus means it is there at least once, but it can match any number of times. And then the asterisk means that it can be from 0 to any number of times. So the difference between the plus and the asterisk is it's at least 1 or more or 0 or more. And so the important thing, it's for the character directly before it. So for example, if you have here the A-B question mark, so that makes the B only optional, not the A and B, just the B. So then you see the matches are A, AB, or AB in this particular case. And then here the other case is with the plus, and you see it will also match the ABB in this case because it's 1 or more times. And then here with the asterisk, you see that means 0 or more times, so it also will capture the A. Good. Then you have character classes, which are the brackets, and they basically, whatever is between the brackets means either one of those characters. So for example, if you have this A, B, C, D in brackets, it means it can be an A, a B, a C, or a D, a single one of those, not multiples, just a single one of those. And then something that I always forget about and can make it very powerful is you can invert it. So for example, you can do the carré, and then it means anything but A, B, C, D. And one typical example it shows down here where you can search for vowels or only consonants. So if you do the carré in front of it, then you only get the consonants. So that's a very powerful way to use these. Any questions, or does anyone want to add something?
No, I think I think like kind of like the base, like just identifying some of the literals and then using quantifiers and character classes are like pretty straightforward.
Yeah.
It's when you start getting into like the more complex, like detect matches and some of that stuff, using some more of the more complex syntax is really interesting. But I
Yeah.
did want to add that I think like my favorite tool that I've used in the past is regex 101. I really like that tool. It's just it's just a like a web tool that you can use. But I also did remember something briefly. Like I came across I'll have to post this to post these two things about the use of regular expressions. One was like regular expressions are a great tool, but don't overuse them. Like one of the sayings is like, um, if you try and solve a problem with regex, now you have two problems. So that was like really like one of those things. And then also like regex is not a panacea to all of your problems. And there was a conversation about identifying like email addresses. Like you think it would be a really, really simple thing to identify, but I'll post the Stack Overflow discussion about it, about like how like even like the simple things that you have, like when you start thinking about specific problems, sometimes it can get really challenging, but probably a little bit more than we were talking about them, but I just thought about them as we were talking, Stefan. So just wanted to share.
Yeah, awesome. Thank you. Yes, I was vaguely quoting that about the two problems. I have heard that too. Like regex is just so challenging and dangerous to use if you get a mistake in it. Or you don't think of its edge cases, right? That's always the challenging thing in programming. And it feels like regexes are just prone to have edge cases you didn't consider. Yeah. Okay. So here now the other option is the pipe symbol or the pipe symbol, the bar. That means alternations. So that those are alternatives. So in this particular case, it either will match with an apple, a melon, or a nut. And you can do the same thing for like repeated vowels, for example. And now it also introduces another function from the string R package, which is called this string detect, is str_detect, and it just returns you a logical vector. So that is what you would use, for example, in the filter function to get only the rows which have a certain pattern. It would be a very common function to use. And yeah, and here you see the output is just going to be the true or false. And what is happening here? Oh yeah, here's the filter function that I just mentioned. So then in this particular case, we would look for any name that contains an X. And then the count function just gives us a count how often the name is in the data set, and then it sorts it by the most common one. So Alexander in this baby names data set would be the most common name with an X in it. Okay, so that is very powerful to use in typical tidyverse data workflows as the string detect. Okay. Then you can also use it to do like counts. So I forgot in which chapter that came up. I think in the number one, you can basically use the sum to then count how many occurrences of that particular pattern you have in your data set. So in this particular case, it's again about the name about how many names have X in it, a lowercase x to be specific, and then it's plotted by year. So you see, for whatever reason, names with X become more popular around, what is this, 1975, 1985? So don't know what that is, but it would be interesting to look at that more in detail. So then two functions that can help you depending specifically on your use case is string subset. Then you get only the part of the word that matches. That can also be your sanity check again when you have more complex patterns. If what you get back is what you expect. Like emails is a typical example. Phone numbers would be a very typical example, right? Then you make sure that you actually get the right pattern returned. And then string which returns you just the index position of each string in your character vector that actually has a pattern. So instead of returning you true, false, it would, for example, for the first position, if that's true, then it returns you index 1 because that's the data it returns to you. Okay. Then string count it tells you how often a pattern is in your word. And so there's different examples. One of the important things about string count is that it doesn't do overlaps. So here in the last example, the ABABABA, you see there would be an ABA pattern 3 times, but it only detects each single occurrence and no overlaps. Then it points out that case sensitivity, and there's different ways to work around it. And I didn't know this, so this was really informative to me. So one way, just in general, is like you could just make everything upper or lowercase with functions, and then look for your regular expression. That would be one way to deal with this, where when you want to make it more predictable. I don't know if that's recommended, but that's what I did in the past. I was like, I didn't want to care about spelling the cases when it doesn't matter, and most of the time, it doesn't. In my experience, when you do these kinds of operations. But here, if you want to ignore the case, then instead of directly providing the pattern, you use the function regx. That's also part of, I think, the stringer package, and then give the pattern, and then you can provide additional arguments. And in this particular case, ignore case is one of them. And here, the other example is what I just said. You could just convert everything to lower. Okay, so, and then in this example, it shows exactly that. You can just change all your strings to lowercase, and that makes it more robust if you search only for lowercase letters, literals, and then it just counts how many vowels they have or how many consonants. And here again, the Corée, very nice way of just capturing a large group of letters. Instead of spelling all of them out, you just spell out which ones you don't want. Very powerful. Okay. Then you can also use a function. Is this also string R, or is this in a different package? I'm not even sure, where you can actually split a string into multiple columns. So that would be also very typical when you have like compound information in a string. Sorry, Colin?
No, yeah, no, I was just gonna add, I think it's tidyr. I was gonna look it up here real quick. I think these separate wider position and whatever. I think it's tidyr, which is kind of confusing because they are helpful for string operations, but I think they are a tidyr
Yeah,
function. But let me just double check. I'll confirm.
yeah, yeah. That sounds right. Yeah, and so here it provides this pattern where like there's like apparently the first name, then gender or sex, and then the age is what I assume. And you see like the typical pattern here, and then you can just use uh, a pretty complex pattern to search for the different components and separate them into a name column, a gender column, and an age column. And so that's very neat if you have those combined information in a single string. Cool. So then there's other things to warn you. So for example, there's too few. That means if for whatever reason any of the strings doesn't have the exact number of components that you try, or columns that you try to isolate, then it will give you a debug option, and then it basically gives you extra additional columns to help you find the cases where that was not where you didn't have a perfect match to find separate that out. And that can be very powerful just to troubleshoot and also be your sanity check that everything is actually working the way you want. I think even if you're not in the debug mode, it will give you a warning, right? I think that's usually those separate functions that give you warning if you get a pattern that's unexpected.
I think the default is an error. I think it defaults error,
Okay.
and then in that case, then I think there are three other options, which are like merge, merge, drop, and then debug, which is the one that you're highlighting here. So I think it's error at the start.
Okay,
But yeah,
that makes a lot of sense. It will basically, yeah, it gives you an error to really point out that you need to fix or think about what's happening so you don't assume your data is processed correctly. Okay. So pattern details. So escapings to match meta character. Oh, escaping. So that's one big thing that we're going to talk about, and it has a very particular interaction with R that we will see. Then anchors help us to specifically search for things that are at the beginning or the end of a string. Then the character classes we already encountered, and then there's like shortcuts to have like very common groups that you might try to match for. Then quantifiers, kind of similar a little bit to the plus and asterisk, but there's even more granular control that you can say how often you want a certain pattern to see. And operator precedence and parentheses. Oh yeah, then there's how are things interpreted in a regular expression we're going to talk about. And then there's also grouping components of the pattern that will also allow us to pull out certain match patterns and things like that. Okay, so we encountered all these. It's already a group of most of these meta characters. We haven't talked about curly braces, and I don't think we talked about parentheses, but those are all meta characters. And if you want to escape them because they're actually part of your pattern you're looking for, you need to add a backslash. And the complication in R comes in that backslash is already an escape in a string for R. So if you want a regular expression that in the end has a backslash in it, then you have to do two backslashes. And so that is tripped me off a lot. Like especially when I was working with character classes, because they start with a backslash and it never worked for me and I didn't understand, and it was because of those. And so this would be an example. If you actually want to match a period, in this case, you have to do two backslashes. The first one is to escape for R, and the second one is to escape in the regular expression, the period. So that's how it works. And yeah, and then if you just do the string view, then you already see what it matches is actually, that's the regular expression it checks for. Okay. And and I thought I read this maybe it's in the R for Data Science book in a different chapter. It calls it toothpicks. So sometimes in R you have in your string, in your regular expression, so many backslashes that there's a lot of them, and then it looks like you just have toothpicks in your string. So be aware of that and just muddle your way through. I don't know I don't know if anyone else has a better recommendation, but it's like it's really hard. Is this in here? One of the other ways to deal with it is to have literal strings in R. I think that's also in this chapter, so we will encounter it. So that sometimes helps to like not wrap your head around it more easily. Okay, and then I think there's just different examples how to match certain patterns. So just yeah, escape a literal backslash you would need for, which is like insane. Okay. Maybe we should talk it through. So for, because the first backslash just tells R you want a backslash. Then that's the second one. Then the third one tells it you want another backslash. And then you end up with two backslashes for the regular expression. And in regular expression, the first backslash will be the escape so you get a backslash. So yes, very hard to wrap your head around. And if you get stuck, Google it. There's, I think, plenty of Stack Overflow that also helps with that kind of thing. Yeah, okay. And then here, yes, raw strings. That's the thing I mentioned. So there's different ways of indicating that you want a raw string, but it basically starts with R and quotes, and then it either is like curly braces, brackets, I don't know why. Does it also work with parentheses? This must be a typo, but I don't know. And so that in this case, you basically say, literally, I want 2 backslashes. That's what I want. And then you can just more easily express what your regular expression is instead of like interpolating what it will be after R processed it. That makes it much, much easier. So in this particular case, it's not that complicated, but as soon as you feel like you have a lot of backslashes, like just do the literal. That helps a lot. Okay, so character classes, we already had this with the brackets and the what did we call it? The anti-set? No, the opposite set. And then you can use other special meta characters that you can use. And so one is the hyphen. So then you can just indicate a range. So from A to Z or from 0 to 9 are very typical, or you can do subsets of that. And then it just talks again about all the escaping you need to do to deal with this. So for example, to have actually not the opposite, you have to do a backslash before that, and then to have a hyphen instead of to indicate a range, you also have to do the backslash. Which then means you have to add a bunch of backslashes when you do it in R. So don't forget that. It's not just going to be a single one. Okay. Oh, just 1 second. I just have to answer a brief phone call, but I'm
So do you have any questions, DJ, about any of this stuff?
No, actually, I'm learning for some of the new things also here. So I don't have any
Okay.
questions. But yeah,
Okay. Are you familiar with regular expressions?
yeah.
Okay. I didn't know how familiar you were with with regular expressions. So yeah, most of the stuff, most of like the escaping meta characters and stuff like that, it's makes some sense. I think the hardest parts will come up when I don't know. There's some other stuff that come up here that I find kind of challenging, especially like the repeated
Yeah.
stuff. But cool. Just wanted to check in, make sure you're doing good.
Yeah, sorry for the interruption, and there's no other questions or addition? Okay, good. Awesome. Okay, so yeah. Yeah, I feel like every time you read a regex chapter or do one of those tutorials, you learn something new, and then you probably forget it. But it's every time I'm like, oh, this is great and really helpful to think about. Okay, and then there's these special character classes that you can use, and so they're indicated by a backslash, and then you just have all these different ones. So one very common thing would be to match digits, and then it's always the lowercase, and then the uppercase is everything that doesn't apply. So this would be anything but a digit would be the uppercase D. And then you have a white space is the S, and then word characters is W. And one thing I find very helpful is actually also \B for word boundaries, because then you don't need to know, is it a tab, a space, or a new line? You just can say, okay, I really want this particular word. I want there to be white space around it. That helps often instead of like, what would be a good instead, if you really want computer and not computerization, then you do a \B to help match that. So I find that one was very helpful when I discovered that special characters. And then there's just all the different examples to show you how they match. I don't think it's worth going through it. It's just it's good to be aware of those groups because they can make your life easier instead of spelling out all the different character classes yourself. Okay, and then the quantifiers we already had, and so the question mark is 0 or 1, plus is 1 or more, asterisk is 0 or more. So we already covered those. And then if you follow the match by curly braces, Then if it's a single number, then you want it exactly that number of times. If there's a period, you say you want that number of times or more. So that's even more specific than the plus or the asterisk. And then if you have two numbers, then it has to be at least that number of times and at maximum that number of times. So that's very helpful. I always forget about that option, I think, to specify things. And I don't know, typical things would be like area code or something like that, right? You always know an area code will have 3 digits, so you can specify.
We use this a lot, like URL strings.
Oh
like
yeah.
if you URL strings, the use of like number matches, especially being able to set a range, is very, very useful. Especially if you have some standard URLs that like follow some general pattern. These are very helpful in that case, I've found. So
Okay. So those is quantifiers, and now it's the operator precedence. And we talked about this before, that when you have A, B, so those are two literals, and then a plus, the plus only applies to B. And you can make this explicit in this particular case by enclosing it with parentheses. And then here it shows you that if you have the two options, it has to either start with an A or end in an B. So yeah, cool. And then whenever you use parentheses, other than help with operator precedence, you can also use it to capture a group. And so in this particular case, back to the first match of the parentheses. So in this case, you want to have two words, two letters, and that makes a capturing group. And then you say, oh, and then I want to match exactly those two letters again, is what this means. So the \1 refers to this capturing group. So whatever it captures, and that's how you can get repeating patterns, basically. And then there's just different examples. Here is like a word that starts with the same letters and ends with the same letters as the other example. I don't know why you would need these things, but it's very neat to see, because it's like sophisticated application where like I don't even would approach this problem this way. I think that's a good reminder.
yeah, this one like was hard for me to wrap my mind around, but like the whole idea of like being able to capture two characters that are repeating one time was just, yeah, this one's challenging for me to wrap my head around a little bit, but I see like the application of it, but I see the theory behind it of why or how it works, but I like the application is challenging for me to see where I would apply
I
this.
would assume you could do here the same by following it in curly braces with 2, right? That should also capture them. And that seems to be more easier to think about than, oh, I want this capturing group. But I didn't know that actually your capturing group can be part of your expression. Like I always knew referring to capturing groups afterwards to extract certain parts of your string. I knew about that. But that it's part of your expression, that was new to me. So yeah. But yeah, I don't know. This thing's also very sophisticated. Okay. And then what is this one here? Back references and string replace. Oh yeah, okay. So here it basically creates 3 matches, 3 capturing groups of any words. So this is word letters, right? And they're separated by spaces. And then the string replace allows you to either replace it with a literal, or you can here use the capturing group. So this would be the first, second, and third. And basically what you say, I want the first word, then the third word, and then the second. So in that way, you can switch it around. No idea. I didn't know that that's a thing you can do. This seems probably good to know, because I could see there's weird cases where that's exactly what you want to do, but I don't know. Oh yeah, for example, it would be like if last name, first name, I would probably first just separate by a period or whatever the separator is, and then switch it around and concatenate the string again. But this thing, you could just do it in one go. I don't know if this is better, but yeah, first thing would be a typical case, I think.
I was thinking that what you were talking about there, like another use case would be like date parsing. So like if you needed to switch your date around, like if you had some like really weird date parsing, or had some like really weird date entry that like, I mean, there's Lubridate, and Lubridate is usually pretty good at identifying date stuff. But if you had like some really weird data entry thing that you had to like swap like the year and whatever, and then have it parse that way, that's what I was thinking that this might be useful for. But it took me a while to wrap my head around what was going on here. But it's just switching the word order for each sentence. So
yeah. So it's also not helpful that we actually don't see the original sentence. So it would have been the birch canoe and not the canoe birch. So yeah. Yes, and I think this is maybe a case where you maybe don't want that many dependencies, that you wouldn't use a package like Lubridate, because often those packages give you more robustness, right? Because they cover all those weird edge cases and you can be pretty explicit. That is hard for you to do it with regex. And I mean, I bet Lubridate does exactly that under the hood, right? It probably uses regexes to kind of resolve those things. Yeah. Okay. Then, so whenever you use parentheses, you get a capturing group. And so when you use the string match function, then it actually returns a array, I think this is, right? Where it shows you the match and then the captured part of the match. And if you don't want that, then you can, instead of just having parentheses, you have in the parentheses question mark colon, which basically says, this is just a group where you, for operation sequencing, right? That's why you have the parentheses in here. Yes, because here you want either the spelling with E or with A. Yeah, so that's one of the other things. Okay, and then we're going to return to those regex flags. So again, this is this regex function that we encountered earlier here, again with the ignore case. And then it just talks about other arguments in here. So, for example, a period would in a regex would not match a new line, but you can basically say dot all, meaning that dot will match anything. To set it to true, then it will also capture new lines. And then the other thing is multi-line true. So if you have a very long string and you have a lot of new lines in it, so for R, that's just a single string. It could be like your whole document, basically, or whole text and the whole novel. The beginning and end would be literally the beginning of the string, and the end would be at the very end of the novel. If you don't want that, but want to capture the beginning and end of the line, then you use the multi-line true. So that's, I think, also very valuable to know, because that's not atypical that you load something in and you just have this gigantic string with a lot of new lines in it. And then but often you're still concerned about each line in your string. So that seems very helpful. I didn't know about it, and it seems like a helpful tool to process that kind of thing. Okay. Oh, and that I also thought was really interesting. So here is a regex flag called comments true, and basically it ignores anything that comes after hash hash mark. And here it's actually using a literal string, so that makes it easier just to spell it out. And I think this, like, if you have very complex regexes, makes a lot of sense. Instead of having a single comment, to have a way to add like a comment for each of the parts of your expression seems a very interesting use case for me. Like, yeah. And I assume it's ignoring spaces here as another side effect of this. But yeah, that seems very powerful instead of having a very complex, long regex where you, I don't know, no one will understand it. Or it will take like half an hour understanding what you did. That seemed very valuable. Yeah, okay. What is fixed? Allows other regulars or to ignore case. Fixed. Okay. So here you basically say instead of using an escape character, you can just say fixed. So I assume that means everything you provide is literal, the literal R string you provide. And then the other thing is with fixed, you can also say to ignore the case to capture more things. Is there any opinion from you two? Like when I said earlier, I would just probably, before I go into regex, make my life easier and just put it all upper and lower. If I don't need the output of it literally in the same capitalization, if I don't care about it, then I would just make my life easier and decide which way I go and then plan my regexes accordingly. Is there a good reason not to do that?
I'll let DJ add in, but I have my opinion, but I don't know, DJ, do you have an opinion? Oh, I think you're still on mute.
I think I don't have any opinion.
Okay.
From my perspective, I think like from an analysis perspective, I usually do that workflow of like just turn everything to lowercase because it just makes life easier for me. But from like an operations perspective, sometimes you don't necessarily want to do that. So like I'm trying to think of in cases, and this is outside of like data analysis, but like if you were trying to do like marketing pieces that are personalized to specific people and you need to have, like capitalization for like first name, last name, you can't necessarily do that operation first of like going all lower because it would look weird if somebody receives that marketing piece with like all lowercase. So from like an analysis perspective, I always usually just go all lowercase and then do it. But like from like an operational perspective, if you were doing something like that using the data for some reason in that way,
Yeah. Okay.
you might not always go to lower.
Yeah. So basically, the rule of thumb would be if the capitalization matters for your application downstream, don't do it. Yeah. Okay. Cool. And then here it uses call for non-English text. That's especially if you have those, what are they called? Radicals, like different things on your letters. This might matter because otherwise, here, for example, the I would be local. Oh yeah, ignore craze. It would not be able to detect that this should also be matched. So you can basically set the locale. So I assume fixed is always English and call is just when you have other locales. Okay, and then it gives just some recommendations for the workflow. So check your work by having positive and negative controls. This is often hard, right? So think of the edge cases, basically. Just think like when you would do like a unit test, same idea here. Like you have examples to make sure you capture the edge cases. Then you can also combine regular expressions with Boolean algebra, because we saw you can also get true and false from regexes. And then you can do complex string manipulation. So it would make, I don't know, it always peeves me, for example, if I have a web form and it wants me to enter it in a certain format. I have all my stuff, like all my phone addresses, my area codes are parentheses, and there's a +1 or whatever the the country code is. So I love it when I just can copy paste it, basically, and don't worry, and it doesn't complain to me, and it processes it just correctly. It seems very valuable. So that would be like one of the cases where regexes come in. And that's it, I guess. Yeah. Okay. I'll stop the share.
No, I think that's a good coverage of it. I have gotten a lot of value, although I, mentioned like before earlier, like, if you use regular expressions to solve a problem, you have two problems. I say that in jest because like I have gotten so much value out of understanding like at least the basics of regular expressions, not only from like an analysis perspective, but from like a data wrangling perspective, but also too from like being able to search a code base really quickly, being able to do like a find and replace operation. Like it it has like maximized my ability to like just from workflow perspective, like increase my productivity by just knowing some of the basics. But I will also say, like, going towards like the more complicated stuff, like as we got towards later on in the chapter, I don't think I've used any of like the really complex things outside of like groupings. I've used groupings before. But yeah, that's my perspective on it. I think regular expressions are good to know, even if you don't use it necessarily for analysis, because there's a lot of like workflow benefits for it.
One of the other things that I saw in the chapter that's not here in the slide deck is that it also says sometimes you can combine multiple stringer functions together. I think that's also very valuable to think about. Instead of capturing it with a single regex, you can think about, okay, how can a subset and just do like Boolean algebra on multiple regexes? That often makes it much simpler and you don't have a complex expression. And it makes it, I thought that was actually very valuable. I forgot which chapter that was, but if anyone hears that, check that chapter in the R for Data Science book, because I hadn't thought about that. That's actually a good way to think about it too. And it makes your regexes so much easier sometimes combining them.
Yeah. Oh, I think we're okay. So I have two ideas here. So like when the one where it was talking about like using like stir flatten,
Oh,
and
yeah.
then like that was a really cool little trick that I saw in this, where it was like it was doing like the color thing, where it was like if you needed to identify colors within your string characters, but like you don't want to like, because like where do you end? Like there's just so many colors.
Yeah.
So it was like, well, a starting place is to maybe use like the already predefined colors inside of R, and then parse that string, and then use, what are they called? Alterations? Or no, they
Yeah.
were called, is it alterations? Just to like
Alternations. Yeah.
alternations. Yeah, alternations. And then just like have a character vector of all those, put those together, and then just like use stir flatten to create a regular expression to identify colors. I thought that was such like a neat trick, and I was like, I'm definitely going to do that now because I think that's
And it
excellent.
makes it also, even if you're like, if you have your own character vector you want to flatten, it makes it more easy to read, because all those like vertical bars, it's still like, what are all the words? It makes it so much harder. And when you want to add something, you don't know if it's already in there. So defining your own character vector and then flattening it into the alternation is really helpful. I actually, in one of my data sets, I'm looking if people in a short answer want to do computer science. And so there were certain, like, first I was looking for COMP, but there were like exceptions where that was not a good match. So I added all the exceptions and flattened them together, and then that made it very easy to remove it. Yeah.
Oh yeah, that's such a, yeah. Anytime that you like get like open responses, like that's where you get a lot of value of regular expressions, is because like there's just so many different ways people use natural language to like represent certain things. And so yeah, definitely able to catch those edge cases is very beneficial. I think we also use that, like when I said with like URL searching and URL parsing, like I always have to say like, hey, if we are going to use a regular expression to identify specific URLs, it may not capture everything because, you know, people enter the data weirdly. There might be like a misspelling somewhere. And like, where do you draw the line? You know, like we could write out all of the exceptions that we have, but there's a certain like point where you're just like, how much more gain are we going to get from like adding to those exceptions? So, but it's very powerful. It is a very powerful tool to be able to like stir flatten them and then just use those to like identify things for sure.
Yeah.
Trying to think of there's something else that I wanted to add about the regular expression. Oh, yeah, I've also found a lot of power in like nesting string R functions, like, you know, stir, lower, and I'm trying to think of like there's like a common pattern that I always come across, and I can't think of it right now, but it was almost to the point where I always did it that I like just like wrote a function for it. I think it was it was like, yeah, it was for like file names. So like, so say you have like a date within a file name, you have like the dashes for like between the year and the day and whatever. And so usually the convention that we follow is to use like under cases, like our underscores. And so like it was always like the process was like stir lower, because we always used to have the slug in the file, which would always have like, you know, capitals and whatever. So it would always be like stir lower, stir replace, you know, dashes to underscores. And so that was like such a common pattern that it was just like, just write a function that nests those functions and then call it like edit file paths or whatever, something like that. And so I found a lot of power of just like nesting string R functions to do like common operations and put it into a function has been really beneficial for me.
Yeah.
All right, cool. Well, does anybody else have anything else that they want to add, or any other like comments or anything to follow up on?
No.
All right, cool. Well, Stephan, I really appreciate you taking on this chapter. It looks like our conversation will take 2 weeks of break here, and we'll come back on the 9th. So I'll see everybody in the new year.
Awesome. Thank you so much.
All right,
Happy holidays.
cheers. All right, we'll
Yeah,
see
thank you,
everybody.
Stephan. Yeah.